Welcome to the first of our Algebra 1 videos. Let's start off with the vocabulary to our first topic, which is writing expressions. We'll start off with algebraic expressions, which are sums and or products of numbers and variables. An example could be something like 2x squared plus 5. In here, I have sums, I have products, but this is what an algebraic expression could look like. A review would be the definition of a variable, which is a symbol used to represent unspecified numbers or values. And we will stick with using letters. Most commonly, N and X are used, but any letter A through Z could be used to represent these unspecified numbers or values. A term is a number, variable, or a product or quotient of numbers and variables. Now, earlier I had this algebraic expression, and the part of this that we need to know is that an algebraic expression like this that has the addition actually is made up of two different terms. These are both terms. An expression is just multiple terms being added to each other or subtracted from each other. A factor is a piece being multiplied to another piece. So if I have 2x, it has two factors. It has 2 and it has x. These are both factors. These two factors being multiplied together create a product, which is an answer to a multiplication problem. And then another piece we're going to see has to do with powers, bases, and exponents. If we go back to what I used for algebraic expression and for term, we had the x squared. That is an example of a power. And the power is made up of the base, which is x, and the exponent, which is the 2. Now let's see how we can use this to translate words into math and math into words. Here is a table to help us with knowing the different terms we could use, such as for addition, we know terms like more than, sum, plus, increased by, added to, and, all together, total of, and combined. I want you to note there are 2 of them that I have added a piece to where it says reverse the order. We'll see that when we do some examples, but we're going to specifically switch the order in which the pieces are given to us. So if I were to say 5 more than x, that is x plus 5. For subtraction, we have less than. Again, we're going to reverse the order. Subtracted from, also reversing the order. difference, decreased by, minus, and lowered by. Next up, we have multiplication. Words that can represent multiplication are product of, multiplied by, times, of. We could use double to mean 2 times, triple to mean 3 times, quadruple to mean 4 times. And then we also have a few geometric pieces, such as area or volume. If we ever see area or volume, they are telling us they want us to multiply some numbers together. And we'll see that later on in the chapter. Next up is division. We'll see division demonstrated in 2 different ways. Division will either be shown using the division sign or as a fraction. And there are certain ways we can tell whether they specifically want a fraction or if the choice is ours. Words for division are quotient of, divided by. We could see a half, which we know is 1 over 2. A third, which is 1 over 3, or to divide by 3. Or if we see the word ratio. One thing we'll have to remember, and we'll review if we need to, is that a ratio is also written in the form of a fraction, and fractions represent division. I added to this a piece about exponents. There are certain key words that help us understand whether we need to have exponents or not. These would include to the power of, to the blank power, so fourth or fifth, and so on, squared, which is second power, and cubed, which is third power. Now we're going to go and put this to use. Our first examples are going to be to write the verbal expression for each algebraic expression. So let's take a look at what's happening here. I want to take a look at our first example. It's got a 3. It's got an x next to it. That x has an exponent. I want to review that whenever a number is set next to a letter like this, that is multiplication. So this is really 3 times x to the 4th power. Now let's write that in words. In fact, what I just said is one possible answer. We could say 3 times x to the 4th power. Now that's not the only answer, but it is an answer. Another possible answer would be, or could be, the product, because we're dealing with multiplication, of 3 and x to the 4th. There is more than one possible answer. One of the things that you're going to have to be able to do is, if I give you a list of possible choices, is to figure out which one best matches the given information. Let's take a look at the next one. Got a couple things going on. It has multiplication, it's got exponent, and it has addition. So one possible answer is 5 times, I'm going to say z squared. It's just a shorter way of saying z to the second power, but you could write it out. Plus 16. I'll go ahead and write out the other example I said. 5 times z to the second power plus 16. So that's the first type of problem we could see. Next up is if I give you words or a verbal expression, you can translate it into an algebraic expression. One of the things I'm going to use with this is we have a problem-solving technique called cubes. And with cubes, we have to circle, underline, box, eliminate some pieces, and solve. I'm going to start with the part where I'm going to circle some information, I'm going to box in some information, just so we can keep track of what is happening. Our first chunk says a number t. Whenever we have this phrase, a number t, that is telling us that the variable t that they want us to use represents some number, but we don't know what that number is. We have more than, and if we look back at our chart, more than tells us plus, and then we have our 6. Now, there is one piece back in the chart that I want you to look back at. Whenever we use more than, it tells you that you need to reverse the order in which the information is given. So even though t is written first, we're going to start off with the 6. So I'm going to say 6 plus, and then t. Now, one thing we might remember is that when I am adding two pieces together, the order in which we add them does not change the answer. So there's actually a second possible answer. And that is, we could say t plus 6. And I'm going to make a side note. So for addition, order does not matter. Now it's only for addition. In our next example, we're going to see that we have subtraction, and in that we will have to keep the order together. But let us take a look. 10 less than the product of 7 and f. So let's take a look. We have our first part, which is the number 10. We have less than, which we know is subtraction. But we also know that means we're going to have to reverse the order. We also have the product. Whenever we see the product, anything after that are pieces that we're going to multiply together. I see 7 and f. So the product of 7 and f, well, we will just write that piece as 7F. So they're set side by side. Now I need to start by flipping the order. So the very first thing I'm going to say is 7F minus, because it's less than, and 10, because that's the number we are decreasing it by. Let's look at another example of this. If at all you think this is going too fast, please pause the video, rewind it back, and start it again to make sure you're catching every piece. Letter C says 2/3 of the volume V. So we start off with 2/3. And though I didn't mention it earlier, this is going to be how we refer to a fraction, one of the possible ways. 2/3 is the fraction 2/3. And I have of. And if we look back, whenever we have of by itself, that means we're going to multiply. And I'm multiplying it by the letter V. So it's 2/3 times V, or just 2/3 V. Now we're going to apply this to more of a real-world type example. I'm going to try to, with each lesson, have some sort of real-life application where you could see this playing out in something that could happen to you someday. Now, this is an example that I made a little personal to me, so let's check it out. Mr. Kruska orders 250 bracelets printed with his band's logo, and 500 stickers with their YouTube and Facebook on them. Write an algebraic expression that represents the cost of the order. So, let's take a look. Let's start off with looking for the important numbers. So, Mr. Kruska ordered 250 bracelets. You will notice I am circling the unit with it, because that's going to come into play. Next, we have 500 stickers. With cubes, we also want to underline what we're asked to do. And a hint here is anytime we have a word problem or like a small story like this, typically the last sentence is going to be that statement or question that tells us what to do. In this case, we are to write an algebraic expression that represents the cost of the order. Now, let's go back and see if we can't find any sort of word that tells us what we're going to do with these pieces. Let's see, Mr. Kruska orders 250 bracelets printed with his band's logo and 500 stickers with their YouTube and Facebook on them. In this case, I have a word and that is connecting these two pieces together. And that tells me that that and is going to be some sort of addition. Let's see what we're going to add. For this algebraic expression, we're going to need some variables. And we're talking for the cost of the order. Well, I don't know any sort of cost of anything. What don't I know the cost of? There are two pieces. Well, the first thing is I don't know the cost of the bracelets. Let's call that the letter B. I also do not know the cost of the stickers. So I'm going to call that S. We are making our expression out of the following information. 250 bracelets, so however much that costs. The and tells me we are adding that to the 500 stickers. Since I do not know how much each of the bracelets cost, I'm actually going to take that information here. I'm going to replace that with B for the cost of bracelets. And I need to multiply that by the 250, so I know how much that costs. B would be the cost of one bracelet. I want to know the 250. Plus, let's see, stickers will be called S, and I'm going to multiply that to 500. And we're going to clean this up by making one small change. Anytime I'm doing a number multiplied by a letter, I'm going to go ahead and just squeeze them next to each other and lose the symbol. So I'm going to say 250B plus 500S. And that would be an algebraic expression that represents the cost of the order. At this point in the video, what I would like you to do is pause the video, and on another sheet of paper or in your notes, we need to solve these questions here at the end. You're going to pause the video, and then once you have answered them and you feel good about your answers, you're going to hit play again. And I'm going to have available for you written out solutions so you can see how you did. So at this time, pause the video, and I'm going to give you the solutions. All right, so as you will see, I put more than one answer for some of these to give you an idea of the possibilities. What I would like you to do is to be able to look at my answers and make the connection to what I wrote and what the problem was asking. I want you to be able to understand what I wrote. Even if you think you might be wrong, I don't want you to get rid of it. I want you to bring that answer to class and ask me questions.